Hello everyone, and we've got extra two topics to cover until the end of the day. And to be honest, I'm still impressed about the previous sessions, especially with the discussion a couple of minutes ago of Maxim and David. And we will publish all the recordings on our YouTube channel, so please don't miss out. And today we are continuing with the next topic, which sounds like smart contract obfuscation, with my colleague Michał Szczepanik, who is our speaker at the conference for the second year in a row. And Michal is a doctor of philosophy and a mobile solutions architect and developer with more than 10 years of experience. He is also a trainer and a conference speaker about Java, Kotlin, Android, Flutter, NFTs, and Web3. You might have met him at one of the Polish or international conference stages. And another interesting fact about Michal is he's a huge fan of Lego and a Halfbike. Let me know in the comments if you know how it looks like. So, hi Michal, how are you?
Hello, hi. Good, thank you. Nice conference.
So, thank you so much.
I hope everyone is enjoying it.
I hope, yes, I hope so as well. And please, a couple of welcoming words from you, and I think we are good to start.
Okay, so hello and welcome everyone. Let's start our talk. As was mentioned, we'll be talking about smart contract obfuscation. And this is, let's say, something which we usually do not consider, at least in the world of the smart contracts, because in most of the cases we would like to be transparent. But there are some cases where we need to think more about our privacy, about our IP work, so intellectual property, about copyrights, or generally we would like to have a little bit secure smart contract that someone will be not able to hack it or copy it that easily regarding the logic. For that purpose, we can use the obfuscation, and let's go and discuss it. So generally some additional words about me. Yes, my name is Michał Szczepanik and I'm solution architect here at EPAM. Most of my life I play with the mobile systems, so maybe this is also the reason why we have this kind of topic, because there we have the challenge that a lot of logic is implemented on the client side in our mobile application. And if we take, for example, the Android app, it's quite easy to take the file with the application and try to convert it, so do the reverse engineering of it to get the almost the same code which programmer create. And to avoid these kind of situations, we need to use a lot of tools for obfuscation, like for Java type of virtual machine, we have ProgWard, DexWard, which is dedicated for Android and stuff like that. So my journey with with cryptocurrencies, the stuff of Web3, etc., started a few years ago, and generally I started playing with Solidity. Then I switched a little bit to Rust. I also like to invest in some interesting projects. Here you see some few of them which are from the Polish market. And for me, it's, let's say, important to know how the smart contract work. But I so many cases where we also need to think about security of the data which we store on the blockchain. Because if we will be talking about the blockchain, we can have this interesting scenario that, okay, everyone knows how the blockchain works, so we have some transactions where we can put also the deployment of smart contracts, keeping everything in the blockchain. So we have one blockchain hash for it. After that, we build the second block when the first is full. We also can hash. We have hash for the previous one, etc., etc. But what happens if someone will, when we discover that something is not okay with our smart contract, or generally we discover that, oh, I shared too much data in my smart contract, and this is, let's say, not the best. And here we will face the one of typical issue which we can have with the smart contracts. If something appears in the blockchain, it stays in this blockchain forever. So we are not able to change our smart contract. And this is one of the challenges which we have now with the smart contract development. So we need to cover a lot of testing, etc. And we really need to think about the logic of our smart contract, which in cases like, for example, NFTs or any kind of contracts where we invest our money, it's, let's say, good to be able to read what exactly this smart contract is about, even from the code perspective. But on the other hand, if we have something in smart contract which is related to our copyrights, or we have some IP algorithms logic inside of them, then we may face another challenge, which is understanding of the data and the fact that we don't want everyone to that easily read what we have in our smart contract. For that purpose, we can use obfuscation. But back to the topic of the blockchain, we generally also have sometimes cases that we have this structure of the blockchain, and we have the conflict because of, for example, some part of the world was disconnected. Let's imagine the scenario that quite easy one. Let's say that Australia was disconnected from the rest of the world. So rest of the world start creating the blockchains on top of our existing blockchain, and they do this. At the same time, in Australia, we don't know about it, and they are taking the stuff which they have locally available, and they're creating similar block on top of the block 2. This may cause that we have the conflict. This may cause that we need to solve everything, and generally is additional risk for us regarding the data which we have in some blockchains. So generally, if, for example, we are able to release our first part of contract as one of smart contract because of the limitation, not always we can expect that the release of the second part will be quite fast valid, because we can have some issue. But this is, let's say, quite a rare situation, at least in current world. But we can expect that sometimes something like that need to be solved. But let's back to the topic of the smart contract and what exactly is the smart contract. So this is some kind of agreement which we can implement using the code. So one party can implement code the smart contract. Then we need to finalize the smart contract rules together with another party, and the smart contract goes live. We can store it in the ledger, so some decentralized storage, blockchain, etc., etc. And the smart contract can be automatically executed when some conditions are met. So, for example, we can have scenario that at some day this smart contract allow you to access something, or from the beginning it give you some access to, for example, some community, anything else, or for example is valid for some time, like after, for example, end of this year, this smart contract will be not valid anymore, so you will be not able to do anything with it. But this is, let's say, in a general vision of the smart contract. And if we think about the smart contracts and why they are better than, let's say, the standard contract, which we have in form of the paper, first is they are secure, autonomous, generally we don't have that much interruptions, trustless, so we don't need the person who additionally signed that we agree on, together on something. Everything is signed by the blockchain and keeping in the blockchain. It's also cost effective, so we don't need to spend that much money to do the operations, but it's also, let's say, global. So no matter where I am, where is the author of the smart contract, I can quite easily buy this smart contract, sign this contract using the blockchain. And also the performance is also much better than the manual signing of the contracts. The final performance, of course, depends on the blockchain which you choose. For example, you can do something on the Bitcoin, which can be a little bit slow. We can consider Ethereum, which is okay, faster than it was previously after merge, but still we have layer 2 like Polygon or whatever, where we can put the stuff and operate much faster. And regarding the usage of the smart contract, we can also have a lot of options. So we can store the data in the contract, so store some records. This is something which in some cases may be good to be encrypted, or may be good to be obfuscated. And generally the difference between encryption and obfuscation is that encryption, generally you convert the data using, for example, some key to something which is not easy to read. And regarding the obfuscation, we are rather changing the structure of the code in the way which is much more difficult to reverse engineering than previously. So in case of encryption, if someone gets the key, he can access our data or break the key. In case of obfuscation, it's, let's say, doable to do the reverse engineering, but it requires some time and also knowledge. Regarding the other activities, we have some trading. So, for example, we can trade some money, whatever. We can consider supply chains, and here, for example, keep the stuff in the loop and know how something is transferred from one point to another, and the logs, for example, which we keep in the blockchain are not possible to be changed, so we will not lose the information. We can consider real estate or mortgage loans, etc., to be used by smart contracts. Employment agreement, why not? We can consider it also as in the concept of smart contract. Copyrights protection, which I mentioned previously, here we rather would like to have the obfuscation. So here we should consider it. Here, we rather would like to be transparent. Also, in case of any contracts which is between me and someone else, we rather would like to be sure what exactly is in the contract and don't have something which is, let's say, difficult to understand. But in cases like copyrights, it's better to hide some stuff. In case of medical care, maybe also because we have some algorithms, etc. In case of voting, here it would be good to be transparent, but I know the cases where the obfuscation was, let's say, quite useful from the security perspective, that no one is able to that easily hack your solution. In case of insurance, we also would like to be rather transparent and if we are thinking about IoTs and other stuff, we may consider the code obfuscation. And moving forward, for example, we have some standard types of smart contract, like contract for tokens, contracts for NFTs, which have some specific structure. So not all the code we can obfuscate. Sometimes also it's, let's say, a little bit risky to obfuscate the stuff there, because it may be recognized as we try to do something wrong and hide. And I saw, for example, the case when OpenSea hasn't presented the NFT because the code of the contract was, let's say, too much obfuscated, and it caused some issues, and they have some security concerns regarding that. Also, we can have different contracts, like the proxy one. So for example, this one, and of course we have much more when we listed than we listed here. But the proxy one is quite interesting and maybe important from our investment perspective. If you buy a contract like that, like proxy one, you buy something which has a value which define the proxy to another contract. And this may cause the problem that, okay, you bought it today or 2 days ago, and today someone changed the value there, and it's pointing to totally different contract than you had when you bought it. So it's, let's say, not the best type of contract to invest money in. But in some cases, we can use it. Regarding the obfuscation, and let's jump to the code, and I will try to be really as much high level as I can during this presentation to, let's say, avoid the problems of understanding something from non really technical people. So we have the code, and this is the code, how it looks like for the developer. It's rather quite easy to read. We have some hello world, we have some values, multiply. And when we add the obfuscation, one of the techniques is that we add a lot of crazy stuff, which causes that the reader don't want to continue reading it, because he sees some crazy numbers, which are also difficult to read, no matter if you are technical or not. And we have a few techniques on the obfuscation level, which we can consider. So, for example, we can increase the code complexity. So readability of it will be much more difficult. And even if originally we had nice, clean code, which is really easy to read and understand, after obfuscation, it looks like the crazy one, which generally require a few hours of analysis to understand what's going on in it. We can also change the control flow obfuscation, and usually in smart contracts, when we play with some addresses, we would like to obfuscate the control flow, so how exactly we are processing the methods, etc., to make it much more complex. And obfuscation regarding the smart contract, which is rather not a big piece of code, can be something challenging, and flow obfuscation is one of the best techniques which we can use there. We have also data obfuscation, so we can, for example, combine few different values together to, for example, an array, and make the readability much more difficult, or split the data. Like, for example, we have some long address or long string, which is something which I usually search because it stores some typical format of data. When we split it, or also do some hash operation to get the value back, we can really cause that it's not that easy to find this value. Like, for example, if we have standard applications, we sometimes have a key, for example, to access some API, etc. It's good to hide it in this kind of concept. Also, we can have cryptographic obfuscation and much more. So generally, you can obfuscate layouts, rename the names in the code, which generally cause that some easy to understand names, like this is sender, this is receiver, will be named like AB and BC. So something which is not that easy to match with some logic. We can obfuscate the controls, so we can complex the flow. We can obfuscate the data. As I mentioned previously, we can merge or split data together to make them a little bit more difficult to read. We can obfuscate classes, methods. So sometimes we can clone the methods to, for example, have some fake method in one place, which looks much nicer and much easier to analyze for the intruder on the first look, but generally is something not fully used in our application. So the logic of it is not the one which is important for us, but may cause that after some time the intruder decide, okay, I don't have time to analyze this smart contract, and switch to another one, or generally the program, if we generalize the obfuscation thing. We have also obfuscation methods concept. So we can, for example, flood the hierarchy of them, drop something, inline something, or extract some part of code to separate methods to cause that it's a much more difficult to follow this method from the flow perspective. And having that in mind, we can move back to the smart contract. And in our system, which typically may looks like that, or with some small modifications, we have some wallets of the user. We can have some our wallet. We operate on the blockchain. Here we have our smart contracts. So, for example, in case of Ethereum, they are written in Solidity. We have some additional storages where we store the data in the centralized form. And having all of that, we can think how we should design this small piece, which is the smart contract. So, smart contract in Solidity Polygon is in Ethereum Polygon is written in the Solidity language, which generally looks like that. Let's start from the hello world. And this is the human readable form of this of this language, and this is how the code looks like. But for the Ethereum virtual machine, this is nothing more like some bytes which need to be executed on the Ethereum virtual machine. And the challenge which we can face with the contracts is not only the fact that we cannot change the contract when we put it on the blockchain, but additional challenge is that, okay, I write some code, it's convert to the bytecode, and to deploy it to the Ethereum network, I need to pay some fee. So I need to pay some gas for the deployment. Cost of this fee represented in gas depends on the size of the bytecode which we have here. So from the developer perspective, we really would like to reduce this thing. And if we would like to check how this code looks like in real on assembly level, we can face something like that. I know that you probably don't see it because it is quite small, but the and this is the representation in Solidity assembly of the same code which we have here. So we have some small methods which we need to play with. And if we would like to do really advanced obfuscation, we shouldn't focus on the obfuscation on this level, which we also covered during this presentation, but we should focus mostly here because this is the part which will be used for reverse engineering of our smart contract. And let's start for some basic concept of obfuscation. So we can rename the names. And here we have the code, which is the original one. And we have, for example, contract deal, some seller, buyer, amount, etc. And we can obfuscate some values by using different names than we had here. So instead of deal, we have ARM 997655422 as a name, etc., etc. We can also, let's say, use some shorter names like AB, BC, or only A for naming. And this is one of the techniques which is used by the obfuscation, and also quite something which quite easily show us that the code is obfuscated. Another technique which we can use is the fact that, for example, in our code we have 3 different arrays, and they are used somewhere later in the code in totally different for totally different things. But we can combine them together to one array, and having something like that, we can play on the specific elements. Of course, it's not that easy to play with something like that, like with the exact array, but it really makes the code much harder to understand for someone who do the attack. Of course, if we are doing the obfuscation, we usually use the tools for that. So we don't need to, let's say, play with the code like that in most of the cases, but we can skip something like that, and obfuscator will do this kind of conversion. Unfortunately, regarding the Ethereum virtual machine, if we will do some basic script which do this conversion of all arrays to, for example, 1, or split them to smaller ones, we may face some limitations of this virtual machine. The details about that are quite complex, so I will not cover it during this presentation, but generally we can do something like that when we know how exactly we use the arrays. And in most of the cases, we should be able to operate with this kind of conversion quite easily. But be aware that you need to test all the cases which you use for your smart contract when you do this kind of obfuscation, because you may hit some issues that the elements in the array will be not recognized correctly. And this is something which may cause some problems for the obfuscators on Ethereum virtual machine, and most of them are not supporting this thing. Regarding the additional, let's say, conversion, we can consider to option to add some fake values which duplicates some existing values and cause that okay, the code size will increase, which may also increase the cost of the deployment of the smart contract. But additionally, we have this case that our smart contract is a little bit more secure because you need to analyze more code. Also, regarding the conversions, we can, for example, do something that easy, like convert the string to some ASCII representation and put this representation into the string, then write some fast converter which convert it back to the right string, or read them a little bit differently, which also may cause that, for example, some obvious strings which appears in your application are not that easy to find. If we will jump to the bytecode level, so to assembly, here is the way how the function selector matching is usually working in case of Solidity. So we have some logic which generally take the address, and then we do the comparison with some exact values, and we do the jump. So from, let's say, high-level perspective, we have some value and a lot of if statements. If the value is that, do that. If the value is that, do that, etc., etc. If we are planning to play with the assembly level of the code, we can consider some small change, like jump this method do the jump only when this is true, so the value is equal another value. But if we use standard jump, this will do this jump, so to the some specific address always. So if we have some fake logic regarding the selecting addresses, we can provide some random values which are never appear in your smart contract, and somewhere in the middle do this jump, which generally cause that we always jump to some different place where we have our custom logic to manage the flow. Reading that by fast review of the code, causing that usually you are focusing on analyzing, okay, this what happened, and you even miss the fact that here we don't have one letter. So also thinking about similar opcodes, we can do some kind of obfuscation. And last but not least, option is to, for example, do the conversion that we have some address. We can split it to two values. And for example, one value is hard-coded, the other one appear like some parameter. And having that, we can combine them together and do the right jump. But we avoid the situation that something long which is expected to be searched by someone who is analyzing our code appears in our code. And regarding the tools, we have one of the tool which is the open source, and to be honest, you can try it on your own because it's not difficult to use. Unfortunately, it's not actively supported, but generally it allows to do conversion. So here you can see the code of the smart contract, and here we see the obfuscated smart contract, and it uses a lot of techniques which I also try. Some of them try to present to you. So do some replace variable names, delete the comments, which is also quite useful feature, and do a lot of conversions. But for example, collapse and merge of arrays not appear there. Also, the convert local variables to state variables is something which is by default turned off, because also in some cases for our Ethereum virtual machine, it may not work as expected. So be aware that when you try to use the obfuscation, you not only need to test your smart contract on, let's say, code level, but also test it after you obfuscate this code, because in some specific cases, the obfuscation or some kinds of the obfuscations techniques may cause that your code may work a little bit differently. And it's not only related to the smart contract, but generally obfuscation in general. Even if we are thinking about the languages that all like Java, we can face this kind of issue. And as I mentioned, depending what you need to do, consider the use cases of your smart contract and if you should apply obfuscation or not. Be aware that obfuscation may increase your code, so the bytecode also increase the deployment code. We have smart contract code limits, so one smart contract has some limitations. I think 24K kilobytes is the limit. Please double check this value because I'm not fully sure right now. But sometimes because of the obfuscation, you need to deploy two smart contracts without cooperating instead of one. And also, let's say it's in some cases, it's much harder to maintain and test these kind of solutions. So having all this in mind, consider it for example, copyrights. If you have something which require to be totally transparent, for the other side, don't use the obfuscation, and of course consider the cost. And right now we have time for the questions.
Okay, yes, thank you, Michal. Thank you so much for your presentation. And the thing I really liked is that is your approach to target non-technical people with such a deep technical topic. And I've got two questions for you from the live chat. And the first one says, can you share any real world use cases or examples where smart contract obfuscation has been successfully implemented to protect sensitive business logic or intellectual property?
Generally, I cannot use the names, but there are some projects which, let's say, some kind of startups nowadays, and they are working on intellectual property secure. So to create the system which will confirm, for example, confirm that you create something, and they are using obfuscation for the smart contracts together with some encryption of the data to generally keep this kind of informations. And based on their pilot, it works quite well. So it's, let's say, doable and can be used also in the real world, but unfortunately, it also increased a lot of the cost of the implementation comparing to, let's say, basic business plans, because, let's say, even basic obfuscation may increase the size of the smart contract around 3 times. So this can be a problem. For example, if we are putting the smart contract on Ethereum network or on the blockchain, Bitcoin network, then we need to think about huge cost. If we choose something cheaper like Polygon, maybe this not affect our wallet that much, but still, it's is, let's say, most the most important thing to consider if you would like to use the obfuscation.
Okay, yeah, thank you so much for covering the pitfalls as well. And another question, I think both of the questions are from the same topic, and it says, are there any regulatory or legal considerations that developers should be aware of when implementing smart contract obfuscation? And
Oh,
mhm,
mhm.
yeah, some additional sentence. How does obfuscation interact with compliance requirements such as know your customer or anti-money laundering regulations?
Okay, so generally, in many cases, we have the smart contracts which are according some standards. And for example, if we are implementing the something like NFT, basic on this standard, there are a lot of quite huge part of the code cannot be obfuscated because we need to have some specific names, etc., according to the standard. Um, in case of obfuscation, this can be used not only for you to hide your logic because this is your intellectual property, which is important for you, but also someone who create the fake contract to generally hide this dangerous part of the smart contract. So obfuscations of the smart contracts, even in some systems or blockchains, uh, are something which generally put additional eyes on what you prepare. Um, I haven't heard about something where, let's say, some well-known solution was blocked because of the obfuscation, uh, but there is a risk that you will be recognized if you are a small player, that you will be banned because some part of code of your smart contract is not clear, or generally it will be mentioned as potential risk of buying this kind of smart contract. So keep this in the consideration. Options are nice and has a lot of possible use cases, but there is, let's say, no strict regulation regarding what can be obfuscated or not. Um, when we know the structure of some standard, like for example for NFT, then we rather know, okay, this part should be as is. This part here we can hide something, but also not with, let's say, much more advanced level. And for example, if we do the magic trick which I provide for the on the bytecode level for address selecting, something like that in case of NFT can be recognized like something really, really dangerous. But if you create some kind of custom solution, then you can consider it there.
Okay, I think that was the last for today. And thank you so much, Michal, once again
Thank you.
for delivering such a great presentation. And I would like to repeat myself that it's kind of uh, easy to understand. Not easy, but it's good to understand for non-technical people. I mean, such a technical topic, and we will publish the recording and maybe get any extra questions from the audience who will be watching it on our YouTube channel.
Yeah, you can always ping me on via email. You can also check my Medium. I expecting that in some time from now I will publish maybe some articles also about the obfuscation, but you can find already some articles about Web3 architecture and stuff like that, or glossary regarding
Sure.
uh,
Yeah. Thank you
the
for letting us
blockchains.
know that.
So
Mhm. Yes.
everywhere you can
Thanks.
find me by name and surname. Thank you and
Yes, thanks
enjoy the
for letting us
conference.
know about your medium. I think that there are not that many Michal Szczepaniks who are solution architects, and your name is kind of easy Googleable, and it's kind of easy to find your medium. And yeah, we will continue the topic of smart contracts on our next session, but we will talk about formal verification with our friend Sergey Yegorov. And please stay tuned. We'll be back in a couple of minutes. And thank you, everyone. Thank you, Michal. And stay tuned. See you in
Thank
a
you.
minute. Bye bye.